here for posterity. I will say, before I jump into the actual lecture, for anyone who's watching me code this, does anyone have any questions as to what I was doing with the CSS, JavaScript, HTML stuff? Nah, that's cool. All right, so cool, we got captions. There's a new sheriff in town. That's the theme of this lecture, I guess you'll call it. So JavaScript and the Wild West. So JavaScript, as y'all have probably gathered at this point, has a reputation for being a bit unruly. So I have a code example in this slide. We start off with something called what am I? And we are converting a string into a number. And then we say what am I plus 1. Then we say, what am I plus 1? What do we get? So I'll actually turn this into a question. Can anyone tell me, what am I? Well, give me the actual values. The actual value. A string 1, 1, this is close. Anyone else want to try? Yes. String 2, 1, right. So yes, string 2, 1, assuming we get past the const error. I shouldn't have made that const. As you all know, I default to const. But yes, so the first thing we get is we have the string 1 converted to a number, and then we add a number to a number. That's what happens. Turn on this thing. In number, we convert the string number 1 into an actual number 1. The next thing we do is we add the number 1 to the number 1, which gives us the number 2. In the next line, we add the string 1 to the number 2. And I believe that this will give us 21, the string 21. Although, given how confusing it is, I'm even second guessing myself and thinking, okay, well, is this actually going to convert the string on the fly into a number? And so this scenario, like how hard it is to look at these 3 lines of code, is an example as to why JavaScript's a bit messy, because everything's happening on the fly, all of these different types floating around. So JavaScript is very forgiving and flexible, as we can see in this example, but sometimes as a developer, we need structure, and I threw out the phrase tough love. And for that structure and tough love, we have something called TypeScript. Captions is basically I lost my captions. The caption is essentially just the new sheriff in town telling us that that must be either a string or a number. TypeScript turtle is, I guess, what we call him, does not like that we're switching between a string to a number to a string. So, question, why learn TypeScript? There's 3 reasons that, for me, I think are good reasons to learn TypeScript. One, really, the essence of TypeScript is that it adds a layer of structure to JavaScript. 2, this is probably more relevant for right now, is that Angular uses TypeScript. So that's like the next lesson that we're going to have is going to be the first part of learning about Angular. And so if we're going to learn Angular, it'd be helpful to have a foundation of TypeScript instead of both at once. And then also, thinking a bit further in the future, thinking 2 steps in the future, when we learn Java, TypeScript and Java have a lot in common. So TypeScript is sort of like a stepping stone between JavaScript and then Java. So what is TypeScript? We talked about it a little bit. So essentially, TypeScript is a strongly typed language. And strongly typed means that it requires that all of our variables, our parameters, and everything are declared with a specific type. JavaScript is not strongly typed. When we create a variable and we so let some number, and we save a number in it, we can change it to a string whenever we want to. It's the types aren't defined and they're not enforced. And so one way to think about TypeScript is it's JavaScript as a strongly typed language. So we're just taking this element of being strongly typed and throwing it on top of JavaScript, not Java. Some examples of strongly typed languages, in case you may have had some exposure to these in the past. Swift, Java, Ruby, C#, and Kotlin or however you pronounce that, are just a couple examples of strongly typed languages. So, visual example, difference between when we see JavaScript code and when we see TypeScript code. So we can see with the JavaScript, this all looks familiar. We're declaring variables, we're saving values in them, or data in them. With TypeScript, there is an additional piece of syntax. We have the variable name, we have the colon, and then we have the type. And so in this example, exact same thing, except colon type. So that's the addition here. A visual example of looking at the difference between JavaScript functions and TypeScript functions it's basically the same thing. So where with a variable we had colon and then the type. With the parameters on the function, we have colon type. This parameter colon type. The other thing we have on the function is we also are going to define what type of data the function returns. And so here, after our parameters in this sort of circle right here, we'll define the return data type. So if this function returns numbers, we're going to say that it returns numbers. I might repeat myself a tad bit here. We just saw this example here about adding a type for each variable. With functions, we're typing each parameter. We have to type what the return is. And if we do not have a return, what type do we use? You might think we'd use the type undefined. That seems reasonable, but what I believe they prefer is to use the type void. And so I'll show you an example of this. This is a function that returns nothing, but it does stuff. It console logs some values. And so what we do is we type it right here with the type void. So objects is where this gets, in my opinion, a bit messier in terms of keeping track of everything. So with an object, we are declaring or we're defining the type of each property in the object. So in this example, we've got 4 properties, and all right, let me just sort of break this down. We have let car is the variable, colon, and then we define all the types up here. After that, have the equal sign, so we're going to assign it some data, and then we store data inside the variable, which is all of this right here. And so make is string. Each one of these is going to correspond to its defined type. Also, to add another layer to this, objects can have optional parameters. So if we're not sure if we're going to save maybe an email inside an object or not, we could put a question mark before the colon right here. So this is defining as optional. If we don't define it as optional, if we don't say email is an optional parameter, and then we assign email there, I believe it will give us an error. But in this example, because it's optional, it does not. So this is where you can kind of get around using these types. And I'm not sure if this is a feature or a bug, but you can add additional properties to an object after you've declared it, after you've created this variable and defined all of its types. You can continue to add new properties to it, even if they're not included up here. So just an FYI, something is possible. I also believe that all right, so hypothetically, let's look at this object, for example. Let's say we tried to set the year down here after we create this entire object. Down here, we say car.year equals 2023, but we put it in quotes, so we're setting it to be a string. So imagine after all this, we try to set the year to a string, which is 2023. What do we think will happen? Anyone? Oh, yes. An error, correct. This is one of those errors that is TypeScript trying to be helpful, and it will give us an error saying that you're trying to set something that's supposed to be a number, trying to set it as a string. And so it will do its best to be helpful and give an error. And so if you add a property like this outside of when we initially create the object, it's not included in the type up here. I believe, from what I've read, I haven't tested this yet, it won't give an error if you switch the type around. So that's why I'm not really sure if this is a feature or a bug of like adding properties after we've initially created the object. But if I remember and we have time, we can play around with it and see what it allows us to do and what it doesn't allow us to do. So arrays, this is another area where if you're used to the flexibility of JavaScript, this can be a bit restricting. So with an array, we can only have one data type. So you cannot do a combination of strings, numbers, booleans, etc. You can only have one data type. And so here, this is how we define an array. We have the variable name, it can be anything. And then we have the data type that we're going to fill our array with. So string, number, boolean, etc. And then we have brackets basically saying that this is an array of strings. That's what this is saying right here. And then we can add our data at that point, or we can use other methods to fill the array with data. You may see this syntax wherever. It's the same thing, practically speaking. So instead of saying string square brackets, it will say something like uppercase array, these carets, and string, and these carets. Right, so just calling that out there so we know that if we see this, it's the same as this, practically speaking. So TypeScript introduces a new data type that we probably haven't been exposed to before unless we're using other languages like Python, and that is something called a tuple. From what I know, tuples are rarely used in the whole TypeScript JavaScript ecosystem, but what they are is they are like an array, very similar to an array, but they have a fixed length, meaning however many items you put in your type array is however many items are allowed to be in the array. Tuples, what makes them also different from an array in TypeScript can have any kind of length. A tuple has a specific length. In addition to that, a tuple can have multiple types of data, where an array can only have one type of data. So this second example right here, this is going to throw an error, because even though we defined the types as string and number, and we added just string number, it's going to throw an error because what is on the right-hand side does not match the length of what is on the left-hand side. The other thing I want to emphasize is if we look at how the type is declared, it's like an array of types versus the type and then the array brackets. Just visually speaking, that's kind of the difference there. So I don't need to go, I guess, too far in the weeds in this, but it's possible to break how tuples are intended to work. So a tuple's really only supposed to have a length that you define here, but I believe you can use like the dot push method or the dot splice or whatever all of the different array methods are. I believe you can get away with using them on a tuple, and that's not intended behavior, but it is something that I bring it up because if you are working with a tuple and you think it's an array and you interact with it as if it was an array, you might be able to get away with that a little bit, but I wouldn't recommend it. Cool, so we'll jump into like a code example and play around with some TypeScript. But I said a lot, and we're covering some new material, so I'd be curious if anyone has any questions or wants me to go back to a different slide or anything like that. Yes? Right, so the way tuples are intended to work, they're not intended to be used with the dot push method. However, it technically works if you were to do that. If you use like the dot push method with a tuple, you don't have to declare the type because you're kind of breaking how it's intended to work. So it'll just let you get away with it, from what I understand. I'm sorry? No, it's something that's not really intended to happen. Yeah, so it sort of debated bringing this up because I'm talking about like non-intended behavior of the language, but I think it would be confusing if you came across this outside of the lecture. So, but yeah, the general rule of thumb would be that when you create a tuple, it should have everything that it will have inside of it. Yes. Can we use optionals? That's a great question. So an optional item in a tuple. I'll need to Google that real quick. See what we find. I believe you can use them in parameters in a function. The question was, can we use optionals in other things? And yes. I think that example is confusing me more than it was assisting. So starting with TypeScript version 3, so that we can assume that in older versions of TypeScript this does not work, we can have optional elements of a tuple. So here we haven't talked about this, but instead of like declaring the type in line right here, let me just zoom in. Instead of declaring the type in line, like we were doing in all of the examples, we're declaring it in line, we're declaring it in line, etc. You can declare the type on its own line and just say the word type, and then you can use that type multiple times. And so in this example, they created a type on its own line. They used the question mark to say that these are optional elements of a tuple. And then here, when they created their tuples, they used the tuple type that they created, and then they were able to get away with having a variety of tuples because they had two other items being optional. Yeah, it's a good question. Cool. Other questions? No? Okay. Let's jump into a code example. I think this should be good. Might already have it up. Cool. So I thought it'd be cool to take a regular JavaScript file and to convert all the items, basically to convert the file from JavaScript to TypeScript. That way we can see syntax we're familiar with and then what it might look like as TypeScript. So here in this file we have a function, we have a loop, we have an if statement, we have a class, and then we're calling different things. So I created a TypeScript file, and it was basically I copied the file and I changed it from .js for JavaScript to .ts for TypeScript. Now, we'll notice, that's probably too much. We'll notice right here that it is not complaining. I don't have any red squigglies. And I believe the reason for that is because, at least the way I have this project configured, it's implied that x is a number and y is a number. But if I were to try to do this, x equals 4, then it complains. So it's implied on line 2 that x is a number, but I could just as well say number. If I were to change it to string, it's going to complain again because I'm telling it it should be a string, but I'm assigning it a number. Let's try also one other thing. I'm going to say let z. And then as soon as I assign z to, then its type is implied. No, it's not complaining. I thought that would complain. It didn't. I gotta fix this now. Cool. So as you may observe, I don't have a ton of working experience with TypeScript. I do, going through this, like, it's kind of made me a bit more of a fan of TypeScript than I used to be, because I really like the free-flowingness of JavaScript, but I think TypeScript is pretty useful. So let's fix this function. Here we have two parameters, a and b. So we're going to set them and say we need to expect numbers into this function. Cool. Now this function is missing one thing. What is it? Return value type, yes. Cool. So what we changed is we set each parameter to be the type number, and then we set the return value to be type number as well. So for this loop, we could probably get away with not setting the type of I, but we certainly can. We don't need to set the type of I anywhere else because we already created it. It doesn't like that, right? It's just when we create this variable, that's when it would be reasonable to set the type. Just like for this if statement, x and y already exist, and we've already defined the type for x and y. So we're not going to do anything like this. That wouldn't make sense because we already crossed that road. So all of this code is the same. Now for the class, I'm going to leave this example broken for a little bit because we're going to talk about classes next. But we can see that TypeScript is not happy with this class right now. Then finally, I'm going to comment this out because I think that it should complain about my function, and I've seen it complain about it. There we go. So here, oh, this is not what I thought it was. One moment. So what I wanted to try was running the function with If we were to call the function with 2 numbers, we're good. But if we were to call it with a string and a number, it is going to very specifically complain about us passing a string into the function, because it says argument of type string is not assignable to parameter of type number, because we're trying to pass an argument of 1, string 1, to the parameter, which is a number, right? So that doesn't work. And this is actually a really good thing with TypeScript, because we're able to protect our code from accidental mishaps like this that might not happen in a simple program, but as this program gets more complex, issues like this are more likely to occur. So let's change this to numbers, but let's say if we were to save the output of this, and I were to set the type of this to string. So because we said that this function returns numbers, and I'm trying to save the return of the function inside of a variable, which I'm also saying it should be a string, TypeScript here is smart enough to say, hey, you're trying to assign a number to something that you're expecting to be a string. So this would be an example of TypeScript actually helping us out. Cool, so we're gonna jump back into the slide deck, but before I do that, with the code that we've worked through, here's if there's any questions on that or something else. No? Okay. So, compiling TypeScript. Last week or the week before, I mentioned that JavaScript is the only scripting language that can run natively in the browser. It is the only language that the browser can run. And so that might bring up a question. So if a web browser can only run JavaScript, then why are we using TypeScript? Or we could make the assumption that, well, maybe the browser will understand that TypeScript is just fancy JavaScript and will run that for us. It's not what's going to happen. The browser still wants JavaScript. And so with TypeScript, what happens is after the TypeScript file is written, it is then compiled. This is kind of a normal process for a lot of languages. You write the script in Java or Python or whatever, and then that is compiled into something else. What TypeScript gets compiled into is JavaScript. And so there are commands to take our TypeScript code, compile it, and then now we have JavaScript code, essentially. This compiled code that we get from TypeScript, this is not code that we're going to be editing or we're going to be adjusting or messing with. This is purely for running it and for using it. But all of our edits would happen in the TypeScript file, if that makes sense. So the command to compile TypeScript is tsc, which is, I guess, their reserved keyword, and then the file name, and that will compile that file. You can also, once you have a TypeScript project set up, I believe there's a command. You can run a command that will compile all of the TypeScript files and put those files into a folder. And so there's more configuration that can happen, but at the base level, it's just tsc and then the file name that you're compiling. So before we talk about classes, pause here for any questions. No questions? Oh, yes.
I've noticed that when the TypeScript is compiled, that it becomes very close to symbolic. I just wondered if there are ever any issues with that, or if anything else might compile, so whatever causes errors that you would then have to change your TypeScript for that.
Right. So the question was, the learner had compiled TypeScript and looked at the outputting at the JavaScript as output. They noticed things like var used in the JavaScript. So the question was, is it possible that the compiled TypeScript JavaScript could be error prone? Is that essentially what you're asking, right? And so the way I'll answer that is hypothetically, maybe something could go wrong with it being compiled, but generally speaking, I would not expect that. And so things like var, as a programmer, we're not going to use them. Typically, probably never, but probably not going to use var as a programmer. But as far as in the code, it's not necessarily a bug in itself, or it's not going to cause our code to break. And so an example, maybe, let's say we write a JavaScript program and it's using the newer ES6 syntax, which allows for things like arrow functions and allows for things like const and let. And so we write our JavaScript using const and let and arrow functions and all the different fun things like the for in loop and the for of loops. Those are great. Those are newer JavaScript syntax. And so let's say hypothetically, there is an older system that needs to run your code. Well, there are tools out there that will compile your code so that it works with the older syntax. And so it'll take the for in loop and change it to just a for loop, and it'll figure that all out for us, do it automatically. It'll take things like constant var and constant let and figure out how to make them appropriately, to how to make them a var variable. And so we'll go through and do all those different things, turn arrow functions into regular functions. And so this whole process of taking something and compiling it to what looks like an older version of JavaScript is sort of a normal thing that happens. And then we're just seeing an example of it with TypeScript. But yeah, great question. Cool. Any follow-up questions to the whole compiling conversation or anything else? No? All right, moving on. So classes. If you remember, classes are essentially a tool for creating objects. With TypeScript, classes are a bit more supercharged. They seem a lot more like classes that you might see in languages like Java that we're going to be learning soon. And so with TypeScript, it will give us more tools for our classes. In this example here, we're not looking at all the additional fun stuff that TypeScript gives us. Instead, we're just looking at how to convert a regular JavaScript class into a TypeScript class. And so here we have two properties. We have name and we have age. And so in our constructor, we will define the types of these parameters. So when we create a new instance of person, we know what the parameters should be. Additionally, we are also setting the types of the properties. So the types of the parameters for the constructor and the types of the properties for the class. And so that happens up there is where we're defining the properties, and right here, parameters. So, mentioned earlier that TypeScript gives us more tools to work with objects. And so it introduces things like access modifiers. We will definitely see these in Java. And so things like, we could say that if a property is a private property, meaning, well, we'll get into the meanings and stuff probably in later lessons. I don't want to go too far down that road. But we can say if it's a private property, a public property, protected, read-only, different things like that, access modifiers. We can set our properties that way. And so that allows us to create these objects that or these classes that are more sophisticated. Yeah, I'll leave that there. So the other thing that TypeScript gives us as it relates to classes and objects that we don't have with regular JavaScript is this programming thing called an interface. interfaces, they exist in other languages. And with TypeScript, we have the ability to use them for classes and objects. So an interface is essentially just setting the types of the different properties for the class or the methods and stuff like that. And so here we can see the example where we create an interface called person, set the name and the age as string and number, and then we can create a new object using that interface. We'll just call person here, and we can create the object. And additionally, for classes, the way they will use an interface is they will say class, in this example student, implements, that's the important keyword here. If we're going to use an interface, we implement the interface, so class implements the person interface. And then from there, we aren't defining the property types at the top of the class. Instead, we just have our constructor. So you may remember when we were exploring one of the questions, we saw like the difference between defining the types inline versus creating something called type, and then we define the types. If you remember that, see if I can show an example of that again. This right here. So where the type is defined on its own line, and then here the type is used. That's the same thing that's happening here, essentially. Technically, you could probably get away with calling this a type, but generally speaking, recommendation is to use it this way, especially when working in classes, because that's sort of how things are talked about, like just semantically. Cool. Let's see here. Before we jump to Studio, I want to take what we learned about classes in TypeScript and go ahead and fix our code. And we will probably be out for Studio early. We'll see. Probably. All right, so the first thing we need to do is, I'll just take a suggestion. What would be one thing I could do to start fixing this class? Parameters. Yeah, these would be the parameters. Type, so I believe name is going to be a string. Age will be number. Right, so we're still missing something. That was a good first step. What's the next step that we need to take here? So I need to declare the types of the properties. Yes. So name, the property is a string. Then age, that property is number. Right. And so we have it that way. What's a different way I could write this class without needing lines 26 and 27 where they are? Yes.
You could say that the class inherits from somewhere, and therefore it would inherit those two, and you wouldn't have to put it within the class.
Right. So yes, so we can say that the class basically is able to inherit these properties. The keyword right is implements. So let's first create the interface right here. Interface. We'll call this, I don't know. I'm sorry, this is lazy. Equals, is that right? Is that the right syntax? Or is it like this? There we go. And so here, that should work. Why doesn't it like it? Person incorrectly implements interface. I'm just going to call this people because it makes more sense. Person incorrectly implements interface people. the type person is missing name and age. Am I doing this wrong? Can anyone see what I'm doing wrong?
It's not capitalized.
Sorry, I heard a couple of different things.
When I was working on it, it wouldn't let me do this either.
It's possible. So one possibility is it is a version of TypeScript issue. But let's chase this one down real quick. Say right here we have interface. So here in this example, they don't use equals. It seems they're not using it with a class yet. Curious if I need to do something like I can try that. And then also get rid of that. Wait, so I said to do quick fix. Did that not work? What did it change? Oh, okay, so this is, I don't love this answer. What it did to fix that error is it added the properties here. In my brain, I'm not exactly sure why I'd use an interface, but I'll come up with a better answer than that. Yeah, so I'll follow up on this. But anyways, so that's what we need to do to get the syntax to work. Unless there's a better reason to use an interface, I'm probably not in TypeScript. Anywho, other questions, comments before we break out for Studio?
So I had the same problem with interfaces.
Mm-hmm.
I was just wondering if it really worked before. The way that it worked just now in the solution, it seemed that it was kind of like basically the enforcement of syntactical and logical elements for the class. But
Right.
in other environments, does it also supply data like you were trying to get this to initially?
No, an interface is not going to supply data. And taking a quick pause, I can think of a way that an interface might be useful. It might be useful if, like, you have more properties. So, for example, let's say we'll change the interface to person, and we will change the class to student, and then we can add other properties here like grade. That should have fixed it. Is it just not catching up yet? Oh. Right, so here might be an example in which I would consider interfaces to be valid. Is let's say we have more of a complicated data structure, and we have the idea of, if you remember the idea of like classes can, I believe they can inherit other classes. An interface is essentially that concept, but just compartmentalized. I guess you could call it to just an interface. So we could have multiple roles. We could have like teacher, we could have, I don't know, administrator, etc. And they could be different implementations of this interface, but the interface would guarantee we have the same base properties. If that makes sense. Yeah. Cool. I'm learning with y'all, to be honest. But yeah, this is good. Great questions. I think we will go ahead and break for studio. We're a bit early, so feel free to get started or take a short break, whatever you need to do.